For this next video, we'll work problem 7 from chapter 4 in Garrett Biochemistry. The question is, calculate the pH at which the alpha carbon group of glutamic acid is 2/3 dissociated. Okay, so our alpha carbon of glutamic acid, which is abbreviated GLU or E, where we need the pH where it is 2/3 dissociated. And our pKa, which you can look up, of this alpha carboxyl is 4.3. So which group are we talking about? We have two carboxylate groups, two carboxylic acid groups in glutamic acid. We have one in the R group, and we have another at the top on the alpha carbon. So we're talking about this top carboxylic acid group dissociating at this pH. So the bottom group has a pKa of 2.2, the R group carboxyl, and therefore it will be fully dissociated when the alpha carbon group is 2/3 dissociated. So we don't need to consider the contribution of the R group carboxyl on this problem. Okay, so we only need to consider this reaction at the top where we have the dissociation of the alpha carboxyl. So we see that the this species makes up 2/3. Okay, so that's our it's 2/3 dissociated. So the alpha carboxyl being 2/3 dissociated will be will make up 2/3 of the species in solution, and on the left our associated species will be 1/3. So what does that mean? That means our, let's get a different color here. Okay, so that means the species on the right is going to be our A minus, and the species on the left is going to be our HA. So we can simply use the Henderson-Hasselbalch equation to do this calculation, where the pH is equal to the pKa plus the log of A minus over HA. Okay, and this is pKa of the alpha carboxyl. Okay, and so we only need to know the ratio here. We don't need to know the exact concentrations in order to do this problem, and we know that the pKa is 4.3 because we can look that up. Okay, so the pH, which is what we're supposed to calculate, is equal to 4.3 plus the log of 2/3 over 1/3, because we've got a 2/3 to 1/3 ratio, and therefore we can cross out the 3's on the bottom. The denominators cancel each other, and that gives us pH is equal to pKa plus the log of 3 over 1. I'm sorry, 2 over 1. Okay, so it's just the log of 2. So we could just, let's just erase this and put log 2. Okay, so the pH is equal to 4.3 plus 0.30, which is equal to 4.6.